We have most likely discovered something gigantic, whose origin is probably extraterrestrial, buried several hundred kilometers deep beneath Africa and the Pacific. These red protrusions, which you see standing out around the Earth's core, are made of material coming from another world, because it's likely made from pieces of another planet. And to understand how pieces of another planet could end up buried inside our own, we'll have to follow a trail that will take us. Witness an impact of incredible violence, a mini-apocalypse, and above all, look into the mysterious origin of the moon. Where did our satellite originate? This intriguing question has kept researchers up at night for centuries. The Earth-Moon pair is unique in the solar system. Earth is the only rocky planet in the system with such a large satellite. Mercury, Venus, and Mars have none. Aside from Pluto and its large moon Charon, Earth has the largest moon relative to its size in the solar system. Our satellite has a radius about a quarter that of our planet and a mass that's about 1/80th of Earth's. Just like the distance that separates us from it today, which you can see in the image, all things considered, it tells us a dramatic story. Due to the laws of celestial mechanics, such peculiarities and distances exist for a reason. You'll see the dramatic scenario is now widely accepted as an explanation. The origin of the moon is surely closely linked to those pieces of another planet that are found buried inside our own. The story starts a few 100 million years after the solar system began forming, 4.425 billion years ago, when primitive Earth, then without satellites, was suddenly hit by a Mars-sized protoplanet, by striking Earth's ancestor at several kilometers per second. This celestial body, which is commonly called Theia, will almost instantly tear away more than a tenth of the total mass of the primitive Earth. Vaporized by the violence of the impact and the temperature, which at the point of impact rises to several tens of thousands of degrees. Hundreds of thousands of cubic kilometers of rock and metal are ejected into space, forming a vast ring of molten debris. And while some of the white-hot elements from this orbiting debris disk fall back to Earth, the rest clump together to form, in a few 100,000 years, what will become the Moon. Our nascent satellite is then covered on its surface by a vast and unique ocean of boiling magma, several hundred kilometers deep. And because of the heat accumulated from the violence of the impact, it will remain in place for nearly 200 million years on Earth. The entire surface melted and reshaped into a global ocean of incandescent lava that covered the planet. It is thought that millions of years of cooling are needed for the surface to harden into a rocky crust, which will often be pierced by intense volcanic activity. This apocalyptic scene of fire and light, where pieces of planets almost instantly went from solid to liquid, before being hurled thousands of kilometers into space, was probably the last colossal collision experienced by our inner solar system. And to see why this doomsday scenario has gradually gained acceptance since the early 1970s. To explain the existence of our satellite, we need to look at the competing explanations that were considered for a time before being eliminated one by one. For example, for a long time, it was imagined that the moon could have formed from a huge chunk of the primitive Earth, which centrifugal force alone would have torn away, when the very young Earth spun rapidly on its axis. Some have even suggested that the immense Pacific Ocean, with no continents on its surface, could be a kind of scar attesting to this event. It has also been suggested that our satellite formed on its own, isolated, before simply being captured by Earth's gravitational field. Or that the Earth and the Moon formed together at the same time, from a single primordial accretion disk. The problem is that, despite their appeal, these hypotheses have all failed at some point to explain certain peculiarities of the Earth-Moon pair. For example, the hypothesis that the moon was torn away from our planet by centrifugal force alone turns out to be false. When we study the details of the lunar orbit, we see that the movement of bodies in orbit is governed by the laws of celestial mechanics. Studying the Earth-Moon system lets us look back to understand its original dynamics. This way, we know that the Earth must have been spinning very rapidly when the moon was formed, and the latter must have been much closer than it is today. By the way, ever since the Apollo missions left a kind of mirror on the lunar surface, we are able to know very specifically the distance that separates us from our satellite, based on the time it takes for the light from a laser to return to us. And this allows us to confirm what the equations of gravity had already predicted. Our satellite is moving away from us roughly at the speed at which our fingernails grow. Now, as it moves away, the moon exerts tidal effects that slightly slow down the rotation of our planet on itself, which slowly but inexorably increases the length of our days. It was calculated and shown at the time it was formed. The moon must have been nearly 10 times closer to our planet than it is today, and the Earth was spinning much faster on its axis back then. 500 million years ago, days lasted 20 hours. 2.5 billion years ago, they were just 12 hours long. And shortly after it formed, about 4.4 billion years ago, the primitive Earth was spinning on its axis nearly 5 times faster than it does today. The length of a day was then about 5 hours. An impressive value, but not enough to rip off large parts of a planet with just centrifugal force. The hypothesis that the Earth and the Moon could have formed together in the same place and at the same time does not explain why. Their cores are so different in size. In fact, our satellite has an extremely small iron core which makes up only about 1% of its mass, whereas Earth's core accounts for nearly 30% of its mass. Yet two bodies that form from the same basic materials should have cores with roughly the same metallic proportions. As for the theory of gravitational capture of a wandering moon, which would have formed elsewhere in the solar system, it was disproved in the 1970s, when the analysis of the hundreds of kilograms of lunar samples brought back by the Apollo mission expeditions showed that the composition of the surface of our satellite was roughly similar to that of Earth's mantle. But if the moon formed in another region of the solar system, it is highly unlikely that it would end up with a chemical composition almost identical to that of our planet. The similar composition of lunar rocks and Earth's mantle suggests both bodies share a common origin. Moreover, studies of the rocks that make up the surface of the moon have shown that in the past it was completely melted. Yet, if the moon had formed on its own, it could never have ended up covered in oceans of lava. Only highly energetic scenarios, such as those involving catastrophic giant impacts, are capable of creating hellish conditions, to the point of melting the surface of a celestial body to depths of hundreds of kilometers. In short, you get the idea. These discoveries arrived in succession, undermining theories that challenged the giant impact scenario, which remains today the only plausible explanation able to account for all the oddities we observe. Over the past decades, researchers have simulated hundreds of planetary collisions, changing their speed, their mass, and their angle of impact, to find one able to create an Earth-Moon pair. With almost identical compositions, very specific iron cores, and orbital dynamics that match what we currently observe, the prevailing scenario is an off-center collision between a primitive Earth with about 90% of its current mass and a Mars-sized planetary embryo, and whose iron-rich core would have, during the impact, penetrated deep inside, to the point of being absorbed and merging with the Earth's core. Which also explains why our planet has the highest density of any in the solar system. During this process, the moon formed from debris ripped from the less metal-rich outer layers. But other scenarios, with different speeds and angles of impact, can also produce similar results. An Earth that has absorbed the majority of the impactor's metallic core. Thus, the collision could have been far more violent than initially thought, and could have involved celestial bodies spinning extremely rapidly on their axes. Or it could have been a head-on collision involving both bodies. Two planetary embryos, each 5 times Mars's current mass, collided nearly head-on, releasing enough energy to completely pulverize both bodies, leaving in place of the impact a gigantic disk of debris. And from this swirling cloud of rock and vaporized metal, the Earth and the Moon would then have been born. The Synestia model explains the composition similarities but still can't fully account for the Moon's unusual current orbit. In short, in any case, whether they are head-on or off-center, the consensus is on the impact, the collision. The main issue with this theory is that the impact's violence destroyed all evidence and clues. And so far, no piece from Theia has ever been observed in the asteroid belt or recovered on Earth in meteorites. Unless you get my point. Some of the missing pieces of the puzzle might be buried beneath our feet, hundreds of kilometers deep. During the 1980s, strange anomalies were indeed discovered deep within the Earth. Vast, enigmatic structures located beneath the African continent and the Pacific Ocean. These clusters of rocks, as vast as our continents on the surface, have been uncovered. Thanks to seismic waves which, by making the inside of the globe creak and tremble, allow us to map its internal structure. Because the speed of these waves and their ability to propagate depend on the nature of the rocks, on the types of materials they pass through. Thus, they can be used, like a scanner, to provide us with a 3D image of the inside of the Earth. Thanks in part to this seismograph placed on the Moon's surface, we know its internal structure. Although our satellite lacks tectonic activity like Earth, it still experiences regular moonquakes. These are caused by meteorite impacts, or by tidal effects that sometimes make its depths tremble. In recent years, maps of the inside of our planet have become more accurate. The two vast, mysterious regions I mentioned are starting to reveal some secrets and outline details. These anomalies, stretching thousands of kilometers and up to 1,000 kilometers thick in some areas, are likely composed of rocks slightly different from the surrounding mantle. Rocks whose particular structure would slightly slow down the seismic waves that pass through them, and thus show us what we believe exists. Fragments of Theia that were neither propelled into space nor mixed with the materials making up the primitive Earth. Partially melted by the impact but mostly intact, these massive blocks, slightly denser than their surroundings, would have sunk into the magma ocean within a few million years, before coming to rest near the Earth's core, where the submerged remains of an ancient planet might lie today. Think about that the next time you set foot on the ground, in Africa or in the middle of the Pacific. Several hundred kilometers beneath your feet, there are the remains of a planet that has now disappeared, and a large part of it helped form the Moon. These massive anomalies also significantly impact our planet. The Pacific one, spanning nearly 3,000 kilometers, is linked to several mantle plumes and many hotspots, while the one located beneath Africa is very likely responsible for the South Atlantic anomaly. It's widely believed the Southern Hemisphere region where Earth's magnetic field weakens exists because of this presence. Thousands of kilometers away, massive volumes of rock with high concentrations of iron contribute to slightly deflecting and weakening our planet's magnetic field. At the level of the South Atlantic anomaly, the number of charged particles from the Sun that manage to make their way close to Earth is much higher than elsewhere. Satellites in orbit there face potentially harmful levels of ionizing radiation. In other words, if the Hubble Space Telescope doesn't take pictures when it passes through here, when they fly over the anomaly, it's because of the buried remains of an ancient planet. And I have to say, I really like thinking about the fact that almost all the elements around us, as well as those that make us up, have come together. Several billion years ago, in the heart of that infernal furnace. By the way, I'd like to share something strange with you. If that impact gave us the Moon, it's also largely responsible for the fact that there's very little gold or platinum on the surface of our planet, just like its satellite. The violent impact, forming magma oceans hundreds of kilometers deep, further increased the uneven metal distribution in the molten celestial bodies. A large part of the so-called siderophile elements, meaning those that like to bond with iron, thus sank to great depths to supply the core with metals. So, almost all of the gold you find today on the surface of our planet was brought here by the late bombardment of meteorites rich in metallic elements. In other words, almost all the gold discovered by humanity arrived on Earth as a result of this collision after the Moon was formed. In space, destruction is never a tragic end in itself, but rather a new opportunity for creation and renewal. From this bright, primordial chaos, the seeds were sown for a pair set into a stable dance. By reshaping and mixing the Earth's crust, this titanic collision may even have helped create conditions favorable for the evolution of life on Earth. Definitely, the end of one world and often the harbinger of the beginning of another.